So now that we are really familiar with FSMs, we can start using them to design some really cool stuff. And the first thing that we're going to learn about designing is sequence detectors. So let me just start off with a sequence of zeros and ones. So let's say this is our sequence. Alright, so this is the sequence that we have, and we want to detect a certain sequence, which is 1011. The first case we're going to look at is when we do not reset. So I'm going to say, put that in orange, not reset. So what does that mean? Okay, so let's see where we're going to detect this sequence. Here we are starting off here, we get a 1011. Boom, we get a detection. Because we don't reset, this 1 can be a part of our next sequence. So if oh look, we have 101. Nope, we don't get a sequence. So here we have it again, 1011. We get a detection. 10, nope. 1, nope. 1, here we go, 1011. And now, because we are not resetting, that means this 1 can be part of the next sequence, so it can be 1011. Now if we do reset, we have to find this sequence all by itself, meaning that the 1 cannot be part of the previous sequence. So in this case we have 1011, we get a detection. Here we have 1011, we get a detection. 1011, we get a detection, and that's it. You can't have this last detection because there needs to be a new 1 to start the new sequence. That's what it means by resetting, that we've reset to then need a new starting 1 to get the next sequence. So in this case, the reset case has 1 less detection than the no reset case. Okay, so how do we create a finite state machine for both the reset case and the not reset case to detect this sequence? We're going to do it for both a Mealy and Moore type machine. Alright, so let's start with the Moore. In the Moore type machine, remember the Moore output is going to be inside of our state. So I'm going to make my legend. I'm going to have a state and my Moore output Z, and I'm going to have an input X. And the input X is going to represent this stream of bits. So it's going to be reading an X one at a time. So this would be the first X, this would be the second X, this 0 would be the third X, etc. Alright, so let's start in state A. And let's first show how we're going to get our 1 output. Now we only get a 1 output Z when we've detected the sequence. So this state is when we're just starting out and we just have zeros. So let's first draw our condition where we're going to get a detection. So if we go from A and we get a 1, we're going to go to state B, because that means we've moved along 1 bit on our way to getting the sequence, because we needed to get a 1 first. Now if we've gotten a 1 and we want to now get a 0 to get to our next step, now we got a 1, 0, so we're moving along to getting our sequence. And each of these states has an output of 0 because we haven't detected our output yet. Okay, so now we're going to state D. So we had a 1, 0, 0, 1, and still no output. And then state E is going to be where our output occurs, because we have a 1, 0, 1, 1. 1, 0, 1, 1 shows this is where we get our sequence. Okay, so now that we know how to get our sequence, we have to take care of all the other possible inputs that we could have. So this right now is showing the case where we get the inputs that we want. We get a 1, 0, 1, 1, and we get a sequence detection. So what happens if we get other bits in between? How are we going to complete this state diagram? Well, before I do that, it's helpful to see what you had to get in order to be in the state. So in state A, we just started with zeros. In state B, we had to get a 1 to get to state B. To get to state C, we had to get a 1, 0. To get to state D, we had to get a 1, 0, 1. And to get to state E, we needed to get a 1, 0, 1, 1. Now this is going to help us as we're going to fill out the rest of this diagram. Okay, so we're in A. Remember, we need to take care of all possible input variations, and we have one input x, so we have to show what happens when x is a 1 and when x is a 0 for each state. So in A, we've already determined what happens when x is a 1. When x is a 0, what are we going to do? We're going to stay in state A. And that's because as long as we keep getting zeros as our inputs, we're going to not proceed on our way to detecting this sequence. Because if we keep getting zeros, we haven't ever gotten this first 1, so we're never going to move along. So we're just going to stay here until we get a 1, and we're going to move to B. Now we're in B. We know what happens if we get a 0. We're going to move along to C. But what if we get another 1? Well, if we get another 1, we want to stay in B. And that's because so long as we keep getting 1s, 1 is always going to be the start of the sequence. So if we just keep getting 1s over and over again, each one of these 1s might be the next start to this sequence. So as long as we keep getting 1s, we're going to stay there until we get a 0. Will tell us that we're going to move to C, because then that moves us along in detecting our sequence. Okay, so now we're in C. We know what happens if we get a 1. What if we get a 0? So if we get a 0, that means we have gotten a 1, 0, 0. And if we got a 1, 0, 0, that totally messes up our sequence that we're looking for. So we just have to go back to the beginning looking for another 1. So if we get a 0, we're going to go back to A. Alright, now in D, to get here we had a 1, 0, 1. We know what happens if we get a 1. We're going to move on to E. What if we get a 0? Well, that would mean we have a 1, 0, 1, 0. Where is that going to lead us? Well, we want it to lead us back to C, because C is the state where you had to get a 1, 0, and that's what we have. If we were here in state D, we had a 1, 0, 1. If we get another 0, that leads us to have a 1, 0, which is what we needed to be in state C. So that's going to bring us back there. Now with E, we've already detected our sequence. So what's going to happen now? It depends on whether we're doing a no reset or a reset case. So let's do the reset case first in blue. So if we are resetting and we're here and we get a 0, we're going to go back to A. Because what that's going to be is a 1, 0, 1, 1, 0, and this is not a new 1 that's going to lead us on the path of getting this sequence. So in our reset case, that's going to be our transition back to A. Also, what if we get a 1? Well, if we get a 1, that means we have a 1, 0, 1, 1, 1. Well, this 1 can now be, this 1 can now be the start of our next sequence. So this 1 could be this 1 for starting the next sequence. Alright, so we've covered everything. Now let's do the no reset case. In the no reset case, we're in E. What if we get a 0? Well, if we do 1, 0, 1, 1 and we get a 0, that means we're already on our way. We can use the 1, 0 as part of our next sequence because that's what starts the next sequence. So where is the 1, 0 state? The 1, 0 state is state C. Now what if we got a 1? If we got 1, 0, 1, 1, 1, well, it's the same thing that would have happened in the reset case, because this new 1 is going to be our way to start the next sequence. Alright, so this is now the finite state machine for this sequence detector, and you can make up a string of bits such as I did here to test this out for yourself. So let's just go ahead and test it with this random string of bits that I decided on. Alright, so let's say here we get a 0. So we start in A and we get a 0. So we stay in A, we get a 1. We're going to move to B, we get a 1. Sorry, we get a 0. We move to C, we get a 1. We move to D, we get another 1. And we move to E. So that is our first detection. Great. So now we're here in E and we get a 0. And we're going to move to, let's say we're doing the no reset case. So let's go to C. Then we get another 0. So we're going to go back to A. Then we get a 1. And we go to B. And then we get another 0 and we go to C. And then we get a 1 and we go to D. And then we get a 1 and we go to E. So that's the next case. So you can test your circuit by creating a random string of bits and knowing where you should be getting the detections and testing out if indeed you do with the circuit you draw, or rather the state diagram that you drew.